Alright, so as we're wrapping up this unit on factoring trinomials, I just want to expose you to two tricks that you can use. I am not endorsing these as the best methods, or that it's even a method that you would have to use. These are just other options in terms of factoring. They're different strategies, and if you are comfortable using them, then you are allowed to use them when it is appropriate based on the situation. These two methods are one we've covered in class, the box method, which is the reverse Punnet square, and a slip and slide, which you may have heard from another class that we haven't covered in our class, but I figured I would show you on here. Alright, let's take a look. So this is the method that you're already familiar with, the reverse Punnet square method. You can see that there are quite a few steps if we actually write them all out. The steps are fine. They do make a lot more sense though when you see them as an example. So my suggestion is that you pause the video, write these steps down, and then we will refer to them as we're going through the problem on the next slide. Alright, let's see an example now. Alright, so here's a trinomial, 4x cubed plus 90x squared plus 45x. If I want to factor this, the first thing that I always look for is a greatest common factor. I notice that my three coefficients all share a factor of 5, and that each term also shares an x. Therefore, I can factor 5x out of each term as my greatest common factor. This leaves me with 5x times the quantity 8x squared plus 18x plus 9. Since that trinomial is already in standard form, I'm going to take my first term, my quadratic term, and write that in the top left corner of my box. In the bottom right corner, I'm going to put my constant term, which in this case is a positive 9. Now I take the lead coefficient of 8 and the constant term, which is 9, and multiply those. And when I do 8 times 9, I get 72. To figure out what goes in the two remaining boxes, I'm basically doing one of the original puzzles that we first did, where I'm trying to figure out what numbers multiply to 72, coming from that product, and add up to the coefficient of the x, what we call the coefficient of the linear term, in this case 18. Some quick trial and error will show us that those two values would have to be 6 and 12. 6 times 12 equals 72. 6 plus 12 equals 18. I'm now going to put 6 and 12 in each of my two remaining boxes. Doesn't matter which one goes in which, and I put an x with each one. What you'll notice is that the interior contents of this box, if they're all added up, will give me 8x squared plus 18x plus 9. I have my 8x squared and my 9, and then these two terms diagonally should add up to 18x, and they do. To surround the Punnet square, I just have to figure out the GCF of each column and row. And I usually go top to bottom and left to right. And that's going to be particularly important looking for negatives, which I don't have any here. The GCF of 8x squared and 6x, which is my first column, is 2x. The GCF of 12x and 9, my second column, is a positive 3. Normally we don't write the positive, but because this is going to be part of a binomial, this will show that it's going to be a plus 3. The GCF of 8x squared and 12x, which is my first row, is going to be 4x. And the GCF of 6x and 9, my second row, is 3. And once again, that's a positive 3. Now I just take my top of my Punnet square, 2x plus 3, and that's going to be one of my factors. Now I got to make sure I hold on to my 5x. But 2x plus 3 is one of my factors. My other factor comes from the side of my Punnet square, which is 4x plus 3. And that is the fully factored form of my original trinomial. I can use a distributive property in any multiplication method to check, but ultimately it will get me back to my original problem. And that's how you use the reverse Punnett square method, also known as the box method, in order to factor a quadratic trinomial. The slip and slide method is another method. Like before, I would suggest that you pause the video to write down these steps and then refer back to them as we're going through the problem on the following slide. All right, let's take a look at an example. Here we have 30x squared plus 51x plus 9. What I'd like to be able to do here is I would like to factor this completely, and as always, I always start with a GCF. I notice that my three terms here all have a common factor of 3. So I'm going to remove the 3, and that will leave behind a trinomial of 10x squared plus 17x plus 3. So this is one of our more difficult trinomials. I don't have a lead coefficient of 1, so I have to use one of the methods that I've used, guessing and checking, reverse Punnett square, anything like that. The slip and slide method is another option, and this is how it works. Over to the side, I'm going to create another trinomial. And I'm going to create it by taking the 10, that's my lead coefficient, and multiplying it by the 3, which would give me 30. And my other polynomial is going to look like this. I'm going to replace the 10x squared with just x squared, keep the 17x, and then look at plus 30. It's as if I have let this 10 slip over to the constant and become 30 with the 3. Now I try to factor this polynomial as I normally would, basically trying to figure out what two numbers multiply to 30 and add up to 17. Pretty quick to see that's going to be 2 and 15. So I can take x squared plus 17x plus 30 and rewrite it as x plus 2, x plus 15. Now, and this is where it's a trick, and it doesn't seem to make a lot of mathematical sense, but it is valid. I'm going to take each of my constant terms in my binomial and divide it by what I originally multiplied the 30 by. So I originally had let that 10 slip over with the 3. Now I'm going to take each of the two constants, the 10 and the 15, and divide each one of them by 10. And it's going to look like this. X plus 2 over 10, x plus 15 over 10. Now here's the really, really important part. You have to reduce the fractions. Don't make it a decimal, just reduce the fractions. Hopefully, because of the nature of the problem, they'll reduce somewhat nicely, but probably not fully. The first one becomes x plus 1/5. The second one becomes x plus 3/2. If you're not sure how to reduce it, it's something you're going to have to look up and try to practice. Now we get to the second part of the name, which is the slip and slide. Whatever I have left for a denominator has to now slide back in front of the x as a coefficient. And that's when I'm allowed to come back to my original problem and rewrite it in a factored form. Keeping my 3, I'm going to take x plus 1/5 and allow the denominator of 5 to slide back in front of the x, keeping just 5x plus 1, my original numerator. The second one, I'm going to take x plus 3/2 and allow that 2 in the denominator to slide over in front of the x. So that's going to be 2x plus 3. And that, believe it or not, is actually going to be the factored form of the polynomial that we were looking for. You can use the distributive property or another multiplication method to check, but a quick check of that will prove that that actually brings us back to our original, and therefore it's a valid factoring. So what we did here is we allowed the lead coefficient to slip over to join the constant, factored a much easier polynomial, and then reduced some fractions to allow the denominators to slide back over near the x to serve as coefficients. So there you have the slip and slide method. It's just another method that you can use in order to try to factor polynomials, specifically quadratic trinomials. I hope this was helpful.